Okay, so I'm going to open up the Brainstem Cross-Sectional Atlas in Sylvius, and I'm going to click on All Structures. And so this opens up a view of histological cross-sections through the brainstem that extend all the way into the spinal cord. So in a different tutorial, I've taken you through the brainstem. So what I'm going to do is jump right to the spinal cord. So I can do so with my navigational window to the left, either just pulling on the sliders or selecting a thumbnail of interest. So what we have here is a cross-section through the cervical segments of the spinal cord, and we can appreciate that from our navigational window. But now I also would expect you to recognize that based on the large ventral horns that we see, plus the abundance of white matter that we see around the outside of this gray matter. And if one looked specifically at the dorsal columns, you'll note that there is a subdivision. And of course, with the color code, we make that easier for you to appreciate. But even without the color code, with a careful eye, one can denote the presence of a small septum that divides the dorsal column region into two parts, a medial part and a lateral part. All right, and just a few other features of note. We've already talked about the very large ventral horns. In the dorsal horn, we have a very striking region of the dorsal horn that corresponds to Rexid's lamina number 2, and that's a region called the substantia gelatinosa. And that's this very bright region here in this section that's made to look like a myelin stain. It's bright because there is a compact zone of small cells with lots of synaptic inputs and not much myelin in this region of the dorsal horn. Now, in the surrounding white matter, I'd point out a few prominent features. I mentioned one major descending pathway. This is the lateral cortical spinal tract. So this is a major means by which the motor cortex sends motor command signals down to the circuits of motor neurons in the spinal cord. So I'm just going to make sure this is selected and just allow you to see through the thumbnails. And so this allows you to note how the cortical spinal tract gets smaller and smaller and smaller as we go from superior to inferior levels of the spinal cord. Okay, back up to the cervical enlargement, and we're ready to move on now to look at the thoracic cord. So think about what's going to be the difference between the thoracic cord and the cervical cord that's in front of us right now. Well, hopefully you have in mind a couple of things. Maybe a small reduction in the amount of white matter that we would see, but perhaps a large reduction in the size of the ventral horn, because we know that the thoracic cord doesn't have to supply motor neurons that govern an appendage, so we would expect a smaller ventral horn there. But you should also now think about the lateral horn, which is a distinctive feature of the thoracic cord. So it's sectioned down one level, and sure enough, we have less gray matter in the ventral horn, and we have a prominent lateral horn, which is mainly there because of a column of cells that are preganglionic sympathetic neurons. That column is called the intermediolateral cell column, and it is essentially why there is a lateral horn in the thoracic cord. We still have a dorsal horn, we still have a beautiful substantia gelatinosa, and we still have quite a bit of white matter because we're still relatively high in the spinal cord at this level. But as we get down to the lumbar enlargement, now the relative proportions of white matter to gray matter seem to be quite different. There's less white matter in absolute terms, but there really is a dramatic difference in the apparent ratio of white matter to gray matter. That's because we're losing white matter, but we also are now adding a very large ventral horn that accommodates the muscle mass of the lower extremities. So we have a prominent ventral horn. Of course, we would expect a sizable dorsal horn receiving sensory signals from the mass of our lower extremities. And then in the dorsal column, I would just highlight for you the fact that we don't have a subdivision that we saw in the cervical and even the upper thoracic cords in the dorsal column, but just a single dorsal column system which is called the gracile tract. So if I select that, and now we can work our way back up the spinal cord, you'll see how the gracile tract is present in the more medial aspects of the dorsal horn, whereas this lateral region is called the cuneate tract. The cuneate tract basically accounts for the addition of sensory axons from the upper extremities. All right, so returning to the lumbar sacral enlargement, and now we can progress to our most inferior section, which is from the sacral cord. So now again, a even greater disparity between the relative amounts of white matter and gray matter. We still have a large ventral horn because we're still in the region of the lumbosacral enlargement serving the lower extremities. We still have a prominent dorsal horn, but we have much less white matter. That's especially evident in a smaller lateral cortical spinal tract that we have in this region, as we're nearly below now the level of gray matter that is going to be subject to the control of our volition. That's one way to think about this lateral cortical spinal tract, that it represents the motor cortex's command capacity over the output of the spinal cord. Well, I think that will do it for this tutorial. I hope this has given you a helpful means of orienting your conceptual knowledge about the organization of the spinal cord to the actual appearance of this beautiful structure in histological sections.